in section 4, we're going to be linking everything we've talked about together to create a generalization for the minimum number of cards that we would need in a pack. Okay? Now, in this case, it's a show that because we've been given the formula. Now, just to recap you, big S was the total number of symbols used throughout the pack, and little s was how many symbols we included per card. And then this is telling us that the minimum number of cards needed is this formula here. Okay? Verify your formula by using the answer to calculate how many cards are required to create a system of 7 total symbols and 3 symbols per card. So let's dig into this. A few important points to refresh. Each set of cards has its own distinct pairs. For example, Dumbledore, Weeping Willow. That pair can only happen on that specific card. And we've noticed from our final diagram that each pair of symbols is linked somewhere in the deck once and only once. If we go back to 1G, we know the total number of pairs from the entire system, if I looked at every single card, is big S times by S minus 1 divided by 2. That is the total number of pairs if you counted up the pairs from every single card. We also know that each card, and again, using what we learned up here, each card has, in this case, 3 choose 2 or 8 choose 2, or it's little s choose 2 number of pairs on that specific card. So that's 2 really important pieces of information that we have moving forward. So total pairs is big S times S minus 1 divided by 2. Okay, and that's for the entire deck. Pairs per card is little s times S minus 1 divided by 2. We know that each of the pairs appears exactly once and only once throughout the deck, and we know that no pairs are shared between cards. Okay, so in this system we can write an expression saying the total pairs is equal to the pairs per card. The pairs per card is a constant, it doesn't change from deck to deck, okay, times by the total number of cards, okay? Now, we have expressions here for the total number of pairs and the pairs per card. So this was big S times S minus 1 divided by 2, which is equal to little s times S minus 1 divided by 2, times by the total number of cards, which we call NS, the minimum number of cards we need. So if we divide this by this, we can find NS. So I'm going to do S times S minus 1, caps, divided by little s times little s minus 1 divided by 2, and that should be the minimum number of cards we need. Now, that's going to be the expression that we were asked to prove. Now, it says verify your formula. So we're going to see if what we think is the formula works for the data we've got by using our answer to calculate how many cards are required to create a system of 7 total symbols and 3 symbols per card. Okay, so that's actually what we've been dealing with so far. So in this case, if we had 7 total symbols and 3 symbols per card, okay, so that would be, I need a little bit more space here. That would be, so we've got 7 is equal to big S, that's your total symbol. And then we have little s equals to 3, which is 3 symbols per card. So we would need to do then 7 choose 2 to find out the total number of pairs is equal to 3 choose 2 times by the number of cards if I'm putting 3 symbols per card. So that way I would need to do 7 choose 2 divided by 3 choose 2, which would be equal to the number of cards required for 3. Now I have a calculator, so I'm going to have to now 7 factorial divided by 5 factorial is 7 times 6. 3 factorial is 3 times 2, which is 6, so I cancel them out. And the answer is 7, which is exactly what we would expect. We already knew from looking at our Levi graph that if I have 7 symbols, I need to have 7 cards. So not only have we created a generalization, we've checked it back with the example we've made, and so far it's working. Now, in section 5, we're going to move on and look at a different type of mathematics. We've already looked at combinations, we've included Levi graphs and a Fano plane, but now we're going to be looking at finite projective plane, and we're going to be making it a little bit more spicy. So stick around for that.